Okay, so we're going to talk about pressure now. Sound pressure, moving past sound intensity, though sound intensity and sound pressure are related. So we often prefer to refer to the pressure associated with the sound wave rather than its acoustic power or its intensity. Pressure is the amount of force per unit area. The unit of measure is newtons, remember force, per meter squared, or pascals. The most common term that we use are micropascals when we're working with sound pressure. So if we say that a particular sound has a pressure of 200 micropascals, we're talking about the absolute pressure of the wave. As with intensity, we can talk about relative pressure in decibels by calculating the log of the pressure ratio. So it's the same idea where we compare an absolute to a reference to get a relative measure. The equation for decibels of intensity should be modified because it can't be used for sound pressure levels. So intense dBIL and dBSPL, intensity level and sound pressure, are related, but there's not a direct relationship. Intensity is proportional to the square of the root mean square pressure. Conversely, root mean square pressure is proportional to the square root of sound intensity. Thus, if the intensity of a sound is increased by 16 to 1, the pressure is only increased by 4 to 1. So you take the square root of 16. If the intensity is increased by 10 to 1, you take the square root of 10. Okay, so intensity and pressure are related, but sound pressure is the square root of the value of intensity. On the flip side, if sound intensity were doubled, the pressure is only increased by the square root of 2. So as sound intensity increases by some factor, the root mean square pressure increases only by the square root of that factor. And as root mean square pressure increases by some factor, the sound intensity increases by the square root of that factor. So this dashed line reflects what it would be like if there was a direct relationship between sound intensity and sound pressure, but there isn't a direct relationship. So sound pressure increases based on the square root of the increase in intensity. So it's the solid line. So they both increase, but intensity increases at a greater, faster than sound pressure. Now, the equation that we use to calculate sound intensity can't be used for sound pressure, but it can be modified. And it can be modified based on what we know about the relationship between sound intensity and sound pressure. So with sound intensity, we have this 10 log equation. Remember, dB, the relative value, equals 10 log base 10 Ix over IR. And remember, with intensity level, our base is 1 times 10 watts per meter squared. Now, with the sound pressure, we're doing 20 log base 10 absolute over our reference. I'm sorry, the reference for watts is 1 times 10 to the negative 12 watt per meter squared. Okay, so going back, we have a decibel is 10 times the log of an intensity or power ratio and 20 times the log of the pressure ratio. With intensity, we're talking about watts per meter squared. With pressure, we're talking about micropascals. So pressure is measured at a different value than intensity. Here's our equation for sound pressure. The decibels, the relative value, equals 20 log 10 absolute over our reference. The only difference between the two equations is that we have a multiplier of 10 used for intensity problems and 20 for pressure problems.